Okay, so in 3.2, we talked about long division. One thing that is important to remember in long division, if you're missing a term, you have to put a 0 in there. So like here, I'm missing the x term, so I would put a 0x. You have to have that placeholder in there. Okay, same with your constant. If you're missing a constant, you need to put a 0 in there. You have to have that placeholder. Okay, so let's look at synthetic division. Synthetic division is very similar to long division. Okay, but the first thing we're going to look at here is this binomial that we're dividing by. Okay, we don't divide by a binomial in synthetic division, we divide by an x value. So we need to solve for x. So x plus 2 equals 0. So we're going to subtract 2 from both sides and we get x equals -2. So that is the number we are going to divide by. The next thing we're going to do is come up here and make sure we're not missing a term. So I have an x squared, I have an x, and I have a constant. Okay, so none of my x terms are missing. My constant's not missing. And now I'm just going to take these coefficients, whether they're positive or negative, and those are what I'm going to bring down here. Okay, so now I'm going to bring my 2, my +7, my +9 down. Okay, first step in synthetic division, bring down that first term. Now in synthetic division, we're actually multiplying to get the answer. That's why it's called synthetic division. So we're going to say, okay, -2 times 2 is -4. Okay, so now I'm going to add those two. So 7 plus -4 is 3. Now I'm just going to repeat it. So -2 times 3 is -6. And when I add those, it gives me 3. So now I'm done. Okay, but let's see what happened here. So we started with an x squared, okay, and an x and a constant. Well, every time we do this, it loses an x. So this was x squared, okay, but now it becomes an x. So we're left with 2x plus 3 and a remainder of 3, and we're going to write it just like we did before over our x plus 2. Okay, just like we did in our long division. So that is our answer right there. Now, one important thing to know about synthetic division and long division too, if you get a remainder of 0, so a remainder of 0 means that whatever you divided by, okay, so that means that divisor is a factor. In other words, if I got a 0 remainder here, that would mean that x plus 2 is a factor. That would mean that x equals -2 is a 0 of this. Okay, in this case, you see I didn't, so I can't do that. Okay, so let's go on ahead and solve this one. So x plus 1/2 equals 0. So -1/2 minus 1/2. So x equals -1/2. Okay, so that's the first thing I had to do. So now -1/2 is what I'm going to divide by. Okay, I have an x squared, I have an x, and I have a constant, so I'm not missing anything. So that's a +4. Notice that this is a -12, so that's going to be a -12 and a 9. My first step always is to bring that first number down, that first coefficient. Okay, now I'm going to do my multiplication. -1/2 times 4 is -2. -12 plus -2 is -14. Okay, -1/2 times -14 is +7. So now 9 plus 7 is 16. All right, so now remember I had an x squared, so these have all lost an exponent now. So it's going to go from 4x squared when we started to 4x minus 14 and then plus 16 over x plus 1/2. So that is my final answer for that problem. So if I was asked, is x plus 1/2 a factor? So is x plus 1/2 a factor? I would say no, because the remainder is not 0. Okay, so let's do the third one. So I have a 6x squared minus 5x minus 6 divided by x plus 3. Okay, so I'm going to set that x plus 3 equal to 0 and solve, and I get x equals -3. So -3 is what I'm dividing by. So I'm going to bring down my coefficients. So 6, -5, and -6. Bring down my first one. So I'm going to multiply -3 times 6 is -18. Okay, and -5 plus -18 is -23. Ooh, this is going to be a big number. Okay, so now -23. So now -3 times -23 is, let's see, -69, positive 69. Okay, -6 plus 69 is 63. So remember, I started with an x squared, and every time I do synthetic division, these have lost an exponent. So x squared goes to an x goes to a constant, and then I have my remainder. Okay, once again, if I'm asked, is x plus 3 a factor? I would say no, because the remainder is not 0. Okay, and we did that in Algebra 2 also, but you have to remember that. And there's also this thing called the remainder theorem. And the remainder theorem says that if you have a polynomial function divided by some binomial or some factor, then the remainder, r, is p of that value. So let's go ahead and take a look. So it says evaluate p of x when x equals 4. Okay. So I'm going to find p of 4. So 4 to the third minus 4 times 4 squared plus 3 times 4 minus 5. 4 to the third is 64 minus 4 times, let's see, what is that? 4 times 16. So 16 times 4 is 64, so minus 64 plus 12 minus 5. So those are going to cancel, and I'm going to be left with 7. So p to the 4 equals 7. But now let's do synthetic division. Okay, so I'm going to take this 4, and I'm going to put in my terms, so my coefficients. So it's a 1, a -4, a 3, and a -5. Okay, and I'm just doing synthetic division, so I bring that 1 down. 4 times 1 is 4, that's 0. 4 times 0 is 0, that's 3. 4 times 3 is 12. -5 plus 12 is 7. So you can see that I got a remainder of 7, and that's what my p of 4 is. Okay, so that's what it's showing here. So here, divide this by x minus 3. So I'm going to put a 3 here. Okay, and I get a remainder of 7. So I know now that p of 3 equals 7. Okay, so the remainder theorem says that if I do division, okay, then my remainder is the answer for when I plug that value in. All right, there's a couple other things we need to talk about. One is the fundamental theorem of algebra, and we've talked about this before, but it's really important. So we're going to talk about it again and again and again. So every polynomial function of degree of n is greater than or equal to 1 has at least one 0, where a 0 may be a complex number. Okay. But we also know a corollary. Corollary is just something saying that it's true. Okay, so every polynomial function of degree n greater than or equal to 1 has exactly n zeros, including multiplicities. Okay, multiplicities, we're going to talk about that, I think, in the next lesson or another lesson or two. Okay, but really what it means is that a zero can repeat itself. Okay, so like you get x equals 6 and x equals 6 2 times. That's fine. Okay, that just means that we'll talk about how the graph actually turns and you can tell it's a multiplicity. Okay, but what this means is if I have a function x to the 4th plus 3x cubed plus 2x squared plus, I don't know, 3, whatever. Okay, that number right there, the degree of the polynomial, is the number of zeros, right, that this function will have. Okay. So what do we know so far? We know that a real number r is a root of the polynomial equation when I set it equal to 0. Okay, or when my y value, right, that's y, equals 0. Okay. We know that p of r, okay, so my remainder equals 0. Okay, so if I plug my remainder in, I'm going to get 0. We know that r, okay, is an x-intercept of the graph of p of x, okay, if our remainder is 0. We know that x minus r is a factor of p of x. Okay. We know that when you divide and it is a factor, then the remainder has to equal 0. And we know that r is a 0 of p of x. Okay, so all it's saying is that if I have some function and I divide by, I don't, this probably, let's see. So if I factor this thing, I'm going to get x plus 3 and x, wait, let's see, change this to a minus 3. So we'll get x plus 3, x minus 1. Okay. So I know that if I divide by x minus 1, I'm going to get a remainder of 0. I know that these are factors, okay, and that this is a factor because, well, I just factored it and I can see that. And I also know that if I solve it, that value, okay, is an x-intercept, okay, or a 0, okay, or a root. Okay. So that's what all this stuff is saying here. So it's everything that we've kind of talked about so far. Okay, and let's take a look at how that actually works. So now it wants us to find a polynomial with these factors. Okay, so in other words, we know that x equals -3, x equals 1/2, and x equals 1. Okay, well, let's go on ahead and find what the factors are. Okay, so these are the roots. Okay, but we need to find the factors. So we're going to have to change it to look like a factor. So remember, if it's in this form, it's a 0. Okay, if it's in this form, it's a factor. So I'm just going to add 3 to both sides so that I get it in a factored form. So there is my factor now. I have to do the same thing for this. I don't like dealing with fractions. So the first thing I'm going to do is multiply both sides by 2. Okay, so now I'm going to get 2x equals 1. Now I have to subtract 1 from both sides and I get 2x minus 1. Okay, and that equals 0. So that's another one of my factors. Okay, so far the two factors I have are x plus 3 and 2x minus 1. Subtract 1 from both sides and I get x minus 1 equals 0. Okay, so there's my third factor. Okay. So now in order to find a polynomial, well, when I'm finding the factors, I'm breaking them apart, right? I'm factoring them. Well, what's the opposite of factoring? Foiling or multiplying. So I'm going to take any two of these, okay, and I'm going to multiply them together. So I'm just going to do these two first, okay, and then I'll do that one. Okay, so I'm going to FOIL. X times 2x is 6x squared. X times -1 is -1x. 3 times 2x is 6x. Okay, don't know how I got 6x squared for that first one. X times 2x is 2x squared. All right. So 3 times 2x is 6x, and then 3 times -1 is -3. Okay, so now I'm going to get 2x squared plus 5x minus 3. But I'm not done because I still have this third factor that I have to multiply by. Okay, so now I'm going to multiply by that. Okay, so I'm just going to multiply x by everything first. Okay, so x times 2x squared is 2x to the third. X times 5x is 5x squared, and x times -3 is -3x. Okay, and now, let's see how many different colored pens I have here. Now I'm going to do -1 times each of these. So -2x squared, -1 times 5x is -5x, and -1 times -3 is 3. So now I'm just going to go on ahead and write it out. So 2x to the third, okay, nothing to combine it with. 5x squared minus 2x squared is going to be 3x squared. -3x and -5x is -8x. And then plus 3. And that is my polynomial that I will have started with. Okay, now notice I had how many factors? 1, 2, 3 factors, which means I had better have to the third power when I finish. Okay, so let's go on ahead and do B here. So I'm just going to do the same thing. X equals 2, x equals 2/3. And x equals 4. Now remember, you can leave this one in fraction form if you want. I just don't like dealing with fractions, okay? Because then I have to multiply out those fractions and add and subtract. Okay? So I'm going to subtract 2 from both sides to start. I get x minus 2. That's my first factor. Multiply both sides by 3 to get rid of that fraction. So now I get 3x equals 2. And then I'm going to subtract 2 from both sides. So I get 3x minus 2. That's my second factor. Subtract 4 from both sides, and I get x minus 4. Okay, and that's my third factor. Okay, now I'm going to go on ahead and multiply 2 of these. I'm just going to start with this one and this one. Okay, so x minus 2 times x minus 4. So as you can see, it doesn't matter which 2 I start with. I'm going to FOIL these out. First outer inner last, x squared minus 2x minus 4x plus 8. So that's going to be x squared minus 6x plus 8. Now I need to multiply by this third factor. So 3x minus 2. Okay, so I'm just going to do the 3x times everything. So I get 3x to the third minus 18x squared plus 24x. And now I'm going to do my -2 times everything minus 2x squared plus 12x minus 16. Sorry, I'm trying to keep this kind of straight. All right, now I'm going to combine my like terms. So I get 3x to the third. -18x squared minus 2x squared is -20x squared. 24 and 12 is plus 36x minus 16. Okay, now it's an important thing to pay attention to. How many factors did I have? 1, 2, 3. So this had better be a 3. Okay, and it is. It matches. We're good. Okay, so let's look at one more thing here. Well, I guess 2 more things here. So one thing is the rational zeros theorem. Okay. Actually, these should be in 3.3. So we'll hold off and do those in 3.3. Okay. And that's it for 3.2. do your synthetic division assignment, and I'll see you guys all next time.